So the end behavior focuses more on the highest power, that's the highest power n, and its coefficients. So this determines the behavior, how the graph will look like, especially the end parts. So for the first one, we have that when n is greater than or equal to 2, as you can see, the end, let me change the color. So this is when n is greater than or equal to 2, meaning even, all even numbers greater than or equal to 2. So the end behavior, the graph will end like this if the coefficient of x raised to power n is positive. So this is when an is greater than 0. So if it's positive, the graph will end this way. But if it's negative, it will end this way. So why the last two is when n is an odd number greater than or equal to 3. This is when n is greater than or equal to 3 and is an odd number. So if an is greater than 0, it will end this way. So that's how it will end. But if it's less than 0, it will end this way. So it's very, very important. We are going to use it later. So look at this. There's what we call maximum number of turning points on a graph of a polynomial function. So if f is a polynomial function of degree n, then the maximum number of turning points is n minus 1. So we're saying that if you have a polynomial of degree n, that's the highest power of x, to get the maximum turning point, how many times it will turn? You subtract 1. So let's look at this example. They said we should find the maximum number of turning points of the following. So for the first one, the degree is n is 2 plus 3. Yes, you add the powers. That gives us the degree. So the degree of this is 5. Therefore, the maximum number of turning points is now 5 minus 1, which is 4. So if you grab this, it will turn at most 4 times. So why the second one? N is 3. Yes, because the highest power is 3. Therefore, the maximum number of turning points will be equal to 3 minus 1, which is 2. So if you grab this, it will turn at most 2. So let's combine this, the knowledge of end behavior and maximum number of turning points, to solve these two equations. So they said, which of the following is the graph shown? So it's a tricky question, but it's still simple. Yes, it's simple. So we are given this graph. So the best way to solve this is use the knowledge of end behavior, maximum number of turns, because we are not given any roots. We are not given any roots. No s-intercept. So as you can see, the end behavior ends here and here. So what do you notice? From what I said, the end behavior here, it must be even. The power must be even, greater than or equal to 2. So we have an even function. So our graph, the highest power must be even. So which of them that the highest power is even? We have 3. So this is off. So, and how do I determine, what will I do again? Okay, using the turning point, the maximum number of turning points, you can see that it turns 1, 2, and 3. So what do you have to say? N must be what? The degree. N must be 4. Yes. For it to have 3 turning points. So which of them has 4? Also 3 of them And again, do you remember that it turns down? So it shows that the coefficient of x raised to power n must be negative, as you can see. Let's go back. Do you remember? They say that a n must be less than what? 0. It will be this. So this is the second graph. The graph will look like this. So in this case, the coefficient of x raised to power n must be negative. So let's go back. So which of them is the coefficient negative? Okay, I have two. So this is off. This is positive. If it's positive, both of them will turn off. So remaining these two, how will I know which one is the actual answer? We now use our extra knowledge, the formal knowledge we know from the beginning of graphing of any function, the x and the y-intercept. Yes, as you can see, I'm seeing y-intercept 2. Meaning if I substitute x, so using y-intercept, meaning x is 0. So if I substitute x as 0, if I get 2, means that's the actual graph. So if I put 0, 0, 0, so this one is off because it will give us -2. So the answer is this. So the answer is option A. So let's look at the second graph. Which of the following is the graph shown? As you can see, you see that the turning, the maximum number of turning points. Okay, let's start with that. We have 1, 2, 3, 4. So meaning n must be 5. Yes. So this is off. So, and again, if you look at the n behavior, it faces down here and faces up. So what do you have to say? Remember, we have 4 categories. So the coefficient of x raised to power n must be positive. As you can see, this is down here, down at the left hand side, up at the right hand side. But if it's negative, the other way around. So this is positive. So the coefficient of x raised to power n is positive. So meaning this is off, this is negative. So remaining these two. Again, using the basic knowledge again, intercept, the y-intercept, you see that if you substitute x as 0, let's know which one gives us -1. Okay, this 0, 0, so this gives us, that's the answer. This is off. So that's the knowledge of, that's all about using maximum number of turning point and also the end behavior of any polynomial function to guess the graph. So it's a very nice approach. Thank you.